Hello everyone. Now we'll discuss about telnet, that is terminal network protocol, which is used in application layer. So in the internet, users may want to run application at remote site and create the outcome that can be transferred to the local site. So this may be the requirement, like some work students have done and they want to get connected to the computer lab in their college, or maybe in the university, and they have done their work at home terminal. So in that case they want to get connected. Now there are programs like file transfer program or protocol, file transfer protocol, mail transfer protocol. Such protocols are available. Telnet is also one of such protocol. Telnet is a general purpose client server kind of a application program. So this is terminal network standard TCP/IP protocol for virtual terminal service as proposed by ISO, that is International Organization for Standards. In general, it is used to establish a dumb terminal session to another computer on the internet. The one of the most important application for remote access. The standard used is RFC 854. What is RFC 854? The purpose is the telnet protocol is to provide general bidirectional byte-oriented communication facility. So its primary goal is to allow standard method of interfacing terminal devices and terminal oriented processes to each other. It is envisioned and that the protocol may also be used for terminal to terminal communication, that is the linking, and process to process communication, that is distributed computation. So this is about RFC 854 standard associated with this particular. Now telnet is a protocol that provides a general bidirectional 8-bit byte oriented communication facility. Telnet is a program that supports the telnet protocol over TCP. Many application protocols are built upon telnet protocol. Now there are possibilities, that is there is a local login when terminal and the respective operating system both are in the same environment. There is a local environment. Before going for this local or remote login approach, time sharing environment is one aspect. Telnet was designed at a time when most operating systems such as Unix were operating in time sharing environment. In such environment, a large computer supports multiple users. The interaction between user and the computer occurs through a terminal, which is usually a combination of keyboard, monitor and mouse. Even a microcomputer can be used as a terminal or terminal emulator. Now, as far as logging is considered, in a time-sharing environment, users are part of the system with some right to access resources. Each authorized user has an identification and probably a password. The user identification defines the user as a part of the system, and to access the system, the user logs into the system with user ID or login name. Now, when the user logs into a local time sharing system, that is what we are showing, that is a local login. The user types at terminal or at workstations running terminal emulator. The keystrokes are accepted by the terminal driver. So it is going to accept that. The terminal driver passes the characters to the operating system. The operating system in turn interprets the combination of characters and invokes the desired application program of utility. The terminal driver is going to access the application programs. This is general thing. Now, in the second category, there is a kind of situation where the user wants to access an application program located on a remote machine, like that is nothing but the remote login. Here the telnet client and server program come into use. The user sends something as a activity to the terminal driver. Then the terminal driver, the local operating system is going to accept but cannot interpret. The characters are sent to telnet client. So this is the first part of the figure. You can see the terminal driver is going to send via that operating system to the telnet client. Now the telnet client will go for the our network model, that is local TCP/IP stack, protocol stack. So that arrow indicates TCP/IP data link physical, that is a TCP/IP stack, and via internet that will pass to the remote server. Again it will get accessed by the server TCP/IP protocol stack. The operating system will transfer it to the telnet server. Then it is transferred to the pseudo terminal driver, and that driver is going to send it to the respective application program. So universal interface called network virtual terminal, that is NVT character set, is used. The telnet client translates the characters or data or commands that come from the local terminal into NVT form and delivers them to the network. The telnet server translates data and commands from NVT form into the form acceptable by the remote computer. This is the basic mechanism. The commands or text in NVT form travel through the internet and going to get accessed at the other end by the TCP stack at remote login machine. Here the characters are delivered to operating system and passed to the telnet server. This changes the characters to corresponding characters understandable by the remote computer. The characters cannot be passed directly to the operating system because the remote operating system is not designed to receive characters from telnet server. It is designed to receive characters from terminal driver. Here the solution is provided by the pseudo terminal driver, which pretends that the characters are coming from the terminal itself. Now the operating system passes these characters to the appropriate application program. The mechanism to access remote computer is a complex one, no doubt, because every computer and its operating system and all the special combinations of characters, everything is to be handled. Here we are dealing with some sort of a heterogeneous system. If we want to access any remote computer in the world, we must first know what type of computer. Then we must also install the specific terminal emulator. Then telnet solve this problem by universal interface, and that universal interface is nothing but NVT, that is network virtual terminal. Now this network virtual terminal NVT character set is transferred from telnet client to telnet server. NVT is going to use two sets of characters, one for data and another one for control. Both are 8-bit byte, that is NVT is an 8-bit character set in which 7 lowest order bits are the same as ASCII and the highest order bit is 0. To send control characters between computers, NVT uses 8-bit character set in which highest order bit is set to 1. Now we will have a comment on this data characters and control characters of NVT. The format is for data characters 7-bit ASCII, essentially higher bit is 0, and for control characters 7-bit ASCII and a higher bit is 1. So data character and control character bifurcation is in terms of higher bit, that is 0 and 1. Now these are some of the NVT control characters. You can see EOF. So this is decimal code is 236, end of file EOR, this is 239, end of record, SE 240, suboption end, NOP 241, no operation, DM 242, data mark, BRK, break, IP, interrupt process 244, AO 245, about output, AYT 246, are you there, EC 247, erase character, EL 248, erase line, GA 249, go ahead, SB 250, suboption begin, will 251, agreement to enable option, won't 252, refuse to enable option, do 253, approval to option request, don't 254 denial of option request is going to deny, and IC is interpret the next character as control, that is 255. Now telnet uses only one TCP connection over well-known port number as 23. This one connection is used for sending both data and control characters. Telnet accomplishes this by embedding the control characters in the data stream. To separate control characters from data characters, each control character is prefaced with the IC control character. So here you can see IC means the next character is a control character. EC means backspace one character. So this is the data, and in between there is a separation as shown, like IC and there is then EC. So this is the way like the embedding is done. The user cannot edit locally. The editing is done at the remote server. The backspace character is translated into two remote characters, that is IC and EC. They are embedded in the data and sent to remote server. This is the data ECAT and all that server, and the client has sent that one control character along with that IAC. So this is the option. Telnet lets the client and server negotiate options before or during the use of service. Options are extra features available to user with more sophisticated terminal. So these are the options: binary, interpret 8-bit binary transmission; echo the data received on one side to other; suppress go ahead signals after data; status, request the status of telnet; timing mark, define the timing marks; terminal type, set the terminal type; terminal speed, set the terminal speed; line mode, change to line mode. To use any of the options, first require option negotiation. Then between the client and the server, 4 control characters are used for this purpose. Here we will discuss about enabling an option, disabling an option, and tree. So these 4 control characters used are will. So 251, offering to enable, accepting a request to enable; won't, 252, that is rejecting a request to enable, offering to disable, or accepting a request to disable; do, 253, is approving an offer to enable, requesting to enable; and don't is 254, that is disapproving the offer to enable, approving an offer to disable, or nothing but requesting to disable. Some options can only be enabled by the server, some can be only be done by the client, and some of them are done by both. So like for example, sender then will, I will enable the option, and receiver may say don't enable the option, do or don't. Then there may be request to enable an option, say do enable the option, will or won't. The receiver may, here for won't it is going to reply don't, and here for don't it is going to reply won't. So that is a small difference in terms of control character. Then sub option negotiation, there is a facility. So here some options require additional information, like to define a correct type or speed of a terminal. The negotiation includes string or some number to define type or speed. So here SE is a character, that is code 240, and meaning is sub option end, and SB is sub option begin with 250 code. The used to control the remote server, and these also characters used to control the application program running on the remote server. Same characters but used